Hi, Mr. Richards here. Today's lesson is on surface area of cylinders. You found the surface area of prisms by adding the lateral area and the area of the two bases. Surface area equaled the lateral area plus two areas of the base. You can find the surface areas of cylinders in the same way. If you unroll a cylinder, its net is a rectangle, and that's the lateral area, and two circles that are the bases. And so the lateral area L of a cylinder with radius r and height h is the circumference of the base, which is 2 pi r, times the height. And if you're wondering why is it the circumference of the base? Well, when you unroll this side here is just the circumference of the base. And so this long piece here is the same as the circumference of the base. So that's where the 2 pi r comes in. The h comes in because that's the height of the cylinder. So 2 pi r gets us this side times h gets us that side. It's just a fancy way of length times width, except it's the length is 2 pi r and the width is h. When you want to bring in the whole surface area, the total surface area, we're going to find the lateral area, plus there's two bases, so pi r squared is one of the circles, 2 pi r squared are both. And here we go with example 1a. Find the lateral area and surface area of the cylinder. Round to the nearest tenth. Let's start off by writing down our formula. Lateral area L is equal to 2 pi r h. Well, our height is going to be the 8, and our radius is going to be the 5. So lateral area is equal to 2 times the 3.14 for pi times the radius, which was 5, times the height, which is 8. When I multiply these four numbers together, my product is 251 and 2/10 inches squared. Now what about the surface area? Well, surface area is equal to the lateral area plus 2 times the area of the base. And of course the area of the base can be written as pi radius squared because the base is a circle. So as we make our substitutions in, the surface area is the lateral area, which was 251 and 2/10, plus 2 times 3.14 for pi, times my radius, which was 5 squared. Well, 251 and 2/10 plus 2 times 3.14 times 25 is 157. When I add that to the 251 and 2/10, I get an answer of 408 and 2/10 inches squared. Now in example 1b, we're given a description of a cylinder that has a diameter of 18 feet and a height of 9.5 feet. Well, with our circles, we do need to work in radii with our radius, and so our radius is actually going to be 9 feet here. And so now we're looking for the lateral area and surface area again. So lateral area is going to be equal to 2 pi r h. And so lateral area equals 2 times 3.14 times my radius of 9, make sure you read carefully to not put the 18 in, times the 9.5 feet. The product of these four numbers is 536 and 94 hundredths. And since I'm rounding to the nearest tenth, we look in the tenths place and look at the hundredths. The hundredths is not going to round that up. The 4 is smaller than 5. So my final answer for lateral area is 536 and 9/10 feet squared. Then to finish this question by finding the surface area is equal to the lateral area plus the area of 2 of the bases. And area formula for the base is simply pi r squared. So the surface area is going to equal 536 9/10 for the lateral area plus 2 times the 3.14 for pi times the 9 for the radius squared. So surface area is equal to that lateral area again, 536 9/10, plus when I take my 2 times 3.14 times 81, since 9 squared is 81, we get 508 68/100. When I add these together, we end up with a sum of 1,045 58/100 feet squared. And again, we need to round to the nearest tenth. That 8 is larger than 5, which is going to cause us to round up for our final answer, that the surface area is 1,045 6/10 feet squared. In our last example of the lesson, a company manufactures dowel rods, and we have a picture of what a dowel rod is. Rod A has a diameter of 3 inches and a height of 12 inches. Rod B has a diameter of 1 inch and a height of 36 inches. Which rod has the larger surface area? Well, let's solve Rod A first. Surface area, so we're going to go straight to surface area, is equal to the lateral area plus 2 of the bases. And if we put in the variables then that we need, the lateral area is 2 pi r h plus 2 times the area of the base, which is pi r squared. Now, be careful, because once again we're given a diameter here of 3 inches, which means our radius is half of that, which is 1 1/2 inches, or just 1 5/10. So surface area is going to be equal to 2 times 3.14 times the 1 5/10 times the height of 12 plus 2 times 3.14 times that 1.5 squared. So the surface area is going to equal, that lateral area ends up being 113 4/100 plus the area of the two circles is 14 13/100 inches. So this surface area is equal to, when we add these up, 127 17/100 inches squared. And if we round again to the nearest tenth, this is going to result in a surface area of 127 2/10 inches squared. And now we get to solve for B. We'll just jump right into our formula now. Surface area is going to equal 2 pi r h plus 2 pi r squared. And this time we're given a diameter of 1 inch, so the radius is going to be half of that, which is 5/10, or just 1/2. So surface area is going to equal 2 times 3.14 times the radius of 5/10 times a height of 36 plus 2 times 3.14 times our radius of 5/10 squared. My lateral area here actually turns out to be the same as the other one at 113 4/100 plus the two circles are where it's going to make the difference. The area of those is 1.57. And so when I add these two up, I get a final surface area of 114 61/100, which when I round to the nearest tenth results in 114 14 and 6/10 inches squared. So to answer my question, which rod has the larger surface area, well, that would have to be rod A. And that is it for this lesson on surface area of cylinders. Good luck.